problem. This is back in 2007. And they give you this condition here where you're supposed to find the solutions or the zeros of this expression right here. They call it the zeros because, you know, you could bring this term to the other side and have an equivalent equation that was equal to 0. I like to call them solutions, right? It's just the solutions to this equation, but it's equivalent terms, I guess. Now, so it says, what is the sum of the zeros? Well, one approach would be just to expand the cubic out, find the, you know, use the cubic root formula, the cube root formula. Cardano's cube root formula, I guess, and do it directly. That's not a lot of fun. It's a very tedious process. Also, you could expand this out and look at the coefficient of the x squared term, and minus that value would actually be the sum of the zeros. So that's not quite as tedious, but tedious nonetheless. A better approach is to actually use a substitution here. And let me show you that there's more than one substitution, but if you take a look at this term right here, you can rewrite this piece as 2 times 12, 2 times the quantity 12 minus x. Okay, I got to get my parentheses nested here. Okay, and then there's a 12 minus x right there, folks. So you see, again, this is straightforward algebra. Just factor a 2 out of here. This is still cubed here, right? Still cubed. Now notice when you cube 2, you would get 8 times 12 minus x cubed. Okay. And you see this right here actually begs for this substitution. See? So in other words, this entire term right here, this would be kind of messy. You would have to raise 24 to the 3rd power. This would just be 8 u cubed right here, right? In other words, allowing for this substitution right here, 12 u is equal to 12 minus x. You can see it right here. This entire term would become the very simple looking 8u cubed. Now notice that 11 minus x, that would just be the same as, what do we need right here? That would be u minus 1. Would be equal to 11 minus x, right? Okay, and in a similar fashion, u plus 1, let me just write it out to the side here. U plus 1 would actually equal to 13 minus x. Okay, you can see where we're going here. It was better off to base the substitution, you know, on this messier term here, and then it turns out you get favorable substitutions. In other words, u minus 1 would go right here. U minus 1 quantity cubed will go right there. And then u plus 1 quantity cubed would go right underneath here. Okay, all equal to this right down here, right? Now that's getting a little messy, but that's exactly what we did right here, folks. U minus 1 cubed plus u plus 1 cubed is equal to u cubed. Now, the hardest part of this, if you want to talk about having to expand out, raise this, you know, this binomial to the 3rd power, is knowing what u minus 1 cubed is. It's not really that difficult. It's pretty well known. U minus 1 cubed is just equal to this parenthetical expression right here. And you can do that by hand or just kind of memorize the pattern. There's a pattern of 3's here. This is sort of related to Pascal's triangle. Again, multiplying this out manually isn't too difficult because of the presence of 1. Now, u plus 1 cubed looks exactly like this, except we lose the minus signs, right? Okay. Now, after that, this is just some simplification. Notice that we have u cubed here and u cubed here. That's 2 of them. So if you take 2u cubed away from 8u cubed, you get 6u cubed, right? Now, a lot of nice things happen, like minus 3u squared cancels with the plus 3u squared. Notice that minus 1 and plus 1 also cancel. And all that's really left is 3u plus 3u, which is the 6u you see over here. And notice we have to bring it to the other side of the equation because you got an equality here, and that's how we ended up with 6u cubed minus 6u equals 0. Now, the solution to this, I've already written it down, are 0, 1, and minus 1, but that's because you can factor a 6 out of this. You can factor, in fact, a 6u. So you can factor 6u times u squared minus 1 would be what's left over, right? Just got one from you. Equals 0, right? So you see, it's clear right here that 1 and minus 1 will make this 0, and of course u equals 0 will make it 0. And that's where these comes from. Now remember, these are the u's right here, right? These are the u variables right here. So we have to link it back to these guys right here, x1, x2, and x3. And so if we use this linkage, I'll just recopy it right here. U is equal, right here we got u is equal to 12 minus x. So for 0, the 0 value of u, okay, is going to give us, and you can do this in any order you want. There's nothing special. I'm going to go ahead and pick x sub 1 first, but the order of the zeros doesn't make any difference. Right? Okay. So y'all, I'm just letting x sub 1 arbitrarily be equal to the first 0, but again, the order of these zeros doesn't make any difference. And so that would imply that x sub 1 is equal to 12, right? No doubt about that. Okay, now what's our next 0? 1. So now we have 1 is equal to 12 minus x sub 2, okay? Again, I don't sound like a broken record here, but the order you do this doesn't make any difference. And so that would tell us that x sub 2 equals to what? That's pretty quickly equal to 13, right? Okay, so we have x sub 1 equals 12, x sub 2 is equal to 13. And finally, what have we not done? Okay, so minus 1, okay, is equal to 12 minus x sub 3. Okay, and what does that tell us? That tells us that x sub 3 is equal to, what do we end up with there? Oh, I think I got these backwards, folks. X sub 2, if you bring x sub 2 over here and subtract 1, you get, this should be 11, I'm sorry. That should be 11. That one should be 11, so we have 12, 11 so far. Now right here is where we're going to end up with the 13, right? If you bring x sub 3 over and add 1, you get x sub 3 equals to, oops. Okay, you have x sub 3 is equal to 13. Now let's not forget what the problem called for. We're supposed to find what is the sum of the zeros. That is, the x sub 1, x sub 2, x sub 3 are the zeros. What is the sum of the zeros? Well, if you add up 12 plus 11 plus 13, that sum is going to be equal to, again, y'all, we're summing these numbers. 12 plus 11 is what, 23. 23 plus 13 is 36. So y'all, the answer to this problem, and you may think, wow, that was kind of tedious, but it's really just busy work. I wouldn't call it super tedious. So the sum of the zeros is 36. And just if you're interested in going further with this, folks, you can expand all this out if you have some time on your hands. Okay, expand all this out and you'll get a cubic equation. The coefficient of the squared term will be minus 36. It's something called Vieta's formula. That's a little more work in my opinion, because you would have to cube this out. You would have to have 24 cubed. And just cubing these binomials with these numbers is a little bit more computationally challenging, but it would be a nice instructive thing to do if you have some time on your hands. Again, if you expand all of this out, you would get a polynomial with minus 36 as the coefficient of the x squared term, and that would prove the result. All right, let me know if you have any questions.